Welcome to STEM Renaissance. Today we'll be teaching Unit 1 of AB and BC Calc, which is limits and continuity.
Continuity is an important property of a function. First of all, the function f of x has to be defined at x equals c, which corresponds to the second condition. This might sound kind of extra sometimes, but think about y equals tangent of x, which is undefined at x equals pi over 2. Then you have to check for the right-hand limit and left-hand limit respectively, because sometimes a function can look kind of like this. As these two conditions are satisfied, you'll need to check if the general limit is equal to the value of f of x at x equals c, which is the third one. Now we'll move on to two important theorems in Unit 1. For the intermediate value theorem, you simply have to remember that whenever a function is continuous on a closed interval, say a and b, then it's going to reach every single value in between like this. For example, if we have a function x cubed between a closed interval 1 and 3, the function will take on every value between 1 cubed, namely 1 and 3 cubed, or 27. When you're answering a free FRQ question on the AP exam, this is sometimes really important because you'll most likely encounter a continuous function as you're dealing with a real-world problem. And you might wonder, why would this be a theorem at all? But always keep in mind, if you're planning to study advanced calculus in college, such as doing sometimes real analysis and above, this will be fundamental and extremely useful in many scenarios, such as when you're doing proof.
It's the motherfucking Eagle Double G.
Snoop Dogg! Where are we now? IVT and squeeze theorem. Provides you with a quick and sometimes much more convenient way to evaluate a limit. The intuitive understanding would be if one function is always stuck between two other functions, when these two functions are equal to each other, the middle function is forced to converge to this same value. Example would be x squared times sine of 1 over x in this graph. You might wonder what this function converges to at x equals 0 without this graph, but think about it this way. You can easily bound this function with negative x squared and x squared, because sine function takes on values only between 1 and negative 1. Therefore, as negative x squared and x squared approaches to 0, as x approaches to 0, the function x squared times sine of 1 over x must converge to 0 as well. These are theorems and some knowledge for today, and we'll demonstrate a few examples to help you understand these concepts now.
Looking at this problem, we start by evaluating the left-hand and the right-hand limit of f of x at x equals 2. Looking at the left-hand limit, we get 6 minus 5 equals 1. And for the right-hand limit, we get cosine 2 pi, which is also 1. That means the limit of f of x at x equals 2 exists, and our first condition has been met. Now we have to check whether f of 2 exists. By looking at the first equation, we get f of 2 equals 1. Therefore, f of 2 exists, and this condition has been met. Lastly, we have to check whether the limit of f of x at x equals 2 equals to f of 2. Since they are all equal to 1, all conditions have been met. Therefore, the function f of x is continuous at x equals 2. Now, let's look at a similar problem. Similarly, by evaluating the left-hand and the right-hand limit of f of x at x equals negative 1, the left-hand limit is just 1 minus 1, which is 0. And we get natural log of 1, which is also 0 for the right-hand limit. Since they are both 0, our first condition has been met. When we check the second condition, we can see x does not equal negative 1 in this piecewise function. H of 1 doesn't exist. Therefore, the second condition is not established. Since we fail to meet all three conditions, h of x is not continuous at x equals negative 1. Now, let's look at a problem related to intermediate value theorem. This is actually a problem provided by College Board for preparing students for the 2020 AP exam. This problem is actually a typical problem that College Board would ask you on AP exam for your knowledge of intermediate value theorem. In order to get full credit for this problem, all you have to say is d of h is continuous on the interval 40 less than or equal to h less than or equal to 60, Since the function d is also differentiable as stated above, by the intermediate value theorem, d of 60 is less than or equal to 3.3, which is less than or equal to d of 40. There's a number h that 40 is less than or equal to h, and h is less than or equal to 60, that d of h equals 3.3. And now you're just done with this problem.